Okay, good morning. Just doing this video real quick because I wanted to show you guys a dependent probability problem using the OR thing because this is from the notes and it was a little bit confusing for my first period class. So um, I want to do this to sort of give you guys a nice little example here. Okay, so a random number from 1 to 10 is chosen. What is the probability the number chosen is even or greater than 6? Okay, so this is a dependent probability problem because you know depending on the thing being chosen, it could be greater than 6 and even, so we have to make sure we account for that. Okay, so if it's dependent or not mutually exclusive, okay, the formula as per our notes is probability of A plus the probability of B minus the probability of A and B. Okay, the probability of A and B. Now we got to take this one step further, okay? Because since it's dependent, okay, the probability of A and B is going to be the probability of A times the probability of B given A. All right, and so we will take a look at this and see what this means. Okay, it really shouldn't be too complicated, and again, I'll draw it up for you guys as well. Okay, so the number chosen is even, so that will be our A. Greater than 6 will be our B. Okay, now the probability that our number chosen is even, okay, the probability of A, okay, even numbers from 1 to 10, there's 5 of them, right? So there's a 5/10 chance of, of an even number, okay? The number greater than 6, well, how many numbers are greater than 6? Well, there's 7, 8, 9, 10. So there's 4 of those numbers out of 10, okay? So the probability of an even number is 5 out of 10. The probability of a number greater than 6 is 4 out of 10. 7, 8, 9, 10. Okay, so now what we have to find is a probability of a number greater than 6 given that it's an even number. Okay, so how do we do that? Probability of B given A. Okay, so the probability of B given A, so we have to break that down into the probability of A, okay, which is 5 out of 10. Okay, so the probability of A, which is 5 out of 10. Okay, now times the probability, all right, that the number is greater than 6. So we have 5 even numbers: 2, 4, 6, 8, 10. Okay, so there's 5 even numbers. That's going to be our denominator here. All right, so even numbers greater than 6. Okay, well, just 8 and 10. There's 2. Okay, so we end up with this fraction of 5/10 times 2/5. One moment. All right, so the probability of B given A. Now this actually cleans up very nicely. Okay, because the 5s cancel out and we end up with 2/10. Okay, which makes sense because what we have is out of our 10 numbers, we have 2 numbers that are even and greater than 6, 8, and 10. Okay, so our probability of A and B, okay, of an even number greater than 6 is 2/10. Okay, meaning, so our probability of A is 5/10. Going to our thing here, our probability of B is 4/10 there. Now we have to minus our probability of A and B, which is 2/10. Okay, so we do that: 5/10 plus 4/10 minus 2/10. 5 plus 4 is 9, minus 2 is 7. So our final answer is going to be 7/10. Okay, so there's a 7/10 chance, or 70% chance, that if we draw a number from 1 to 10, the number is going to be even or greater than 6. Okay, now let's draw this up. Okay, so if we have 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it actually cleans up pretty nicely. Okay, the formula works, but if we have sort of a smaller sample space, we can sort of run this. Okay, so that the number chosen is even, so 2, 4, 6, 8, 10, right? Or the number is greater than 6, okay? Which means that 7 and 9 can be included in this thing too, okay? So what happens is look at all the numbers that are selected that fit the bill. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6, there's 7, and there's 10 total, okay? So that makes the probability 7 out of 10. That's a nice, easy little example right there if we have a dependent probability using the word or, okay? So there's a couple problems on our notes that look like that, and so that's sort of how it is going to set up, okay? So we'll talk about it if we need to, and your discussion question is going to look like this as well. Y'all take care.